Our first regular presentation, and the title of the presentation is called Spam Campaign Cluster Detection using Redirect URL and Randomized Subdomains. And authors Abu and Dibya and Shahid and Alan and Gary. It's a speaker here. Yes, can you come over here, please?
Okay, good morning everyone and welcome to my presentation, and I'm also taking the opportunity to invite you one more time to the conference as I am the first presenter of this conference. So I am Shoeb, I am from University of Alabama at Birmingham. So I'll be talking about spam campaign detection. And before going detail, here is the outline of my talk. Introduction, then I will say why spam detection is important, and then why it is difficult to detect. Then I will explain our approaches and results, and finally after the conclusion I will take the questions. So first question is this terms I will be using these terms throughout my presentation a lot of times, so I want to give you the idea. I know what everyone knows what is spam email, but one more time I want to clarify it. This is unsolicited email, which we also call junk email, and this is like not only annoying to us but also dangerous. And then next term is spam campaign. This is a campaign who sends spam email to promote the same product, and they actually use the same template to send the spam email. And then redirected URL, actually this is the main key of our research. So what is redirected URL? Actually we when we receive a spam email, there is a URL, so this is called given URL. So when we process the given URL, we ultimately find another URL. So this is the call we are calling redirected URL. And finally, randomized subdomain. For example, they use different subdomains, and when we process subdomain as our secondary key to detect our spam email campaign. So now why spam campaign detection is important. So if you look into the statistics, according to the Kaspersky Bulletin in 2013, we received 70% email is spam. So now you might think then, oh, I don't receive that much spam email in my inbox. Actually, this is the number that your mail server receives. Then they filter it, then they send it to you. So after filtering, you receive the rest of the spam email. So this is the percentage that actually your mail server receives that much spam email. And second part is malware infected users help spammers to harm user. Sometimes you even don't know. For example, you act to a spam email, you click on their given URL, then you are infected. And then the spammers use your machine to harm other people. So you don't even know that you are helping spammers to harm other people. And in large organizations, they always have a lot of process to identify the infection. So if we are able to detect this spam campaign, we would be able to save their time to react the infections. And finally, for example, if in every day if you receive 100 emails in your inbox, where only 10 emails are useful and rest of them are spam, so it's really difficult to find the useful emails throughout the 100 emails. So this is why it is important to us to detect the spam campaign. So why it is difficult? The main reason is the spammers change. For example, when we receive an email, it has certain attributes. For spam email, it has subject, it has URLs, but the spammers changes this subject very frequently. Spammers changes this URL very frequently. So if you have a predefined rule to detect them or filter them, actually your filter doesn't work just because of this dynamic property of spam email. And moreover, when they have URLs, they always change these URLs. So if you use blacklist to block this URL, actually it doesn't work when they changes their URL. And second part is criminals hide their identity. So if you want to trace them, sometimes, as I have already mentioned, they use your computer. When you are infected, they use the compromised user computer to harm other people. So this is why it is difficult. And last thing is we don't have access to instantaneous spam email. For example, in many places, for example, we have a model to detect spam email. So what we do, we have plenty of spam email. we analyze them, now we have a model, then we apply it. But by this time, spammers already reached their goal, right? So we have to access the instantaneous spam email to detect the spam campaign instantly. So this is why it is difficult, as we don't have access to the spam email when it reaches our mailbox. So here is our approach. This is the overview. So why given URL? Like we are calling the given URL is the URL that comes in the spam email. So why given URL? Because this in most of the spam email, given URL is available. So we can process it, and this is the like certain attribute that comes with every spam email. Then why campaign, not an individual spam? Because campaign is the superset of spam. Under a campaign, they send thousands or millions of spam emails to user. So we target campaign, not to detect spam. We target to detect a campaign. And why redirected URL? As I already mentioned, in their email, they give you a URL which is a big URL, and they changes it very frequently. So if you try, but eventually it points, like lots of given URL points to a single URL. This is what we are calling redirected URL. So this is why redirected URL is the main key of our spam detection. So if you look into the block diagram, at the very beginning, we have the spam emails data set. Then we treat them like every spam email, we treat them as a cluster, singleton cluster, which has one single spam email. Then we process their redirected URL. We process their given URL. Based on this given URL, we got the redirected URL. And in level 1, for example, we have thousands email point to one redirected URL, so they goes to one cluster. Similarly, based on this redirected URL, we form the cluster in level 1. In level 2, the rest of the spam emails are considered based on their subject. So we do like exact subject matching in level 2, then we form level 2 clusters. And in level 3, what we do, we process the given URL, we extract the given URL, and from the given URL they have like different subdomain. So we process this given URL and we find the exact domain instead of subdomain. So in third level, we process them based on their domains. And finally, for example, we might have some outliers in our clusters, so we apply different threshold value, for example 50, 100, 200 to remove our outliers. So here is the like more description of our algorithm. In level 1, I have already mentioned you that we use redirected URL. So this is the key in our level 1 algorithm. In level 2 clustering, we use exact subject matching. So here our key is exact subject matching, and in that phase we also merge some subjects with our level 1 clusters. Why we do this? Because in some cases when we process the given URL to find the redirected URL, in some cases we don't find their redirected URL because it doesn't reach the original machine. So when we cluster in level 1, for example, we have one redirected URL and we have 100 emails comes to that redirected URL. So they have a subject set. In level 2, we also match this subject with the level 1 subject so that they can go to to that cluster as well. And finally, we use randomized subdomain. I have like in result section, I have example of redirected URL and randomized subdomain. So in third level, we extract the given URL. So we remove all of these subdomains. So we find the domain, then we merge them based on their domain. And in our case, we use threshold, like maximum threshold is our 500, because we thought that like if I'll show you that in most of the cases when we found like most prominent cluster, it has like more than 50,000 emails in one cluster. So in that case, if one cluster contains only 500 emails, we just discard them. Less than 500, we just discard them as outliers. So in University of Alabama at Birmingham, we have a center. This is called the Center for Center for Information Assurance and Joint Forensics. So actually, this center is mainly responsible to gathering spam emails from various sources, and we are given that data for our research purposes. And we processed 500,000 spam emails in our research. So at first level, we are given a data set from 15 April, which was a data of 16 hours because our center collects the data in every 15 minutes. So we got the data for 6 hours to build our prototype. Then we apply our algorithm to the data of 20 and 21 August. And the attributes that we are given from them is subject and given URL. And from these two, we found redirected URL. So we are calling this attribute as derived attribute. And finally, we use like plain and simple Python language because Python have a very good library. If you are familiar with Mechanize, Mechanize is a library that actually helps you to emulate or browse a URL through using the Python. So this is how we got the redirected URL. So here is the example of redirected URL. If you look into this, this is generated from data of 20 August. Here you see we have like 5 different URLs. These are actually comes in your email, in spam email. So these 5 actually like eventually point to this single URL. So this is what we are calling redirected URL, and this is the key attribute of our research. Then randomized subdomain. If you look into this, see in everywhere the original domain is rhin.ru, but they use different subdomain just to like make fool the user, so they might think that this is a different website, so they click it, but eventually it points to the domain rhin.ru. So here is the results. Is it pretty impressive? So look into that. So we have data of different time period. In 15 April, we have data around 60,000 spam email. So we have like different level of clusters. In first level, if you look into the column 3, by using the redirected URL, this spam emails has been reduced to 17,000 clusters. And in level 2, same subject, it has been reduced to 1086, like almost 1,000 clusters. And when we apply subdomain, then it has been reduced to around 300 clusters. And finally, when we apply threshold, we got only 4 clusters. So which actually represents the original 4 campaign, not spam emails. So out of 60,000 spam emails, we have got 4 prominent spam campaign. Similarly, we apply the same algorithm to 20 August data. Here we have 249,000 spam emails. Similarly, in level 1, it has been reduced to small number, and eventually when we apply the threshold, we got 18 URLs. But out of them, I will show you that only 4 or 5 are the prominent spam campaign. And at last, we thought, okay, let's merge the 2 set of data and see if they have any like common in spam campaigns, and we found the same thing. Like in my next slide, I will show you that eventually when we merge both of them, we found that only 4 major campaigns are there out of this 500,000 data. So here is the result based on data of April 15. If you look into that, see how these are the number of clusters. So we are saying we have 1, 2, 3, 4, 6 clusters. I didn't include rest of them because if you look into the graph, see first one contains almost 36% of spam email out of 60,000 spam email, right? And in level second cluster, they have 32%. In third cluster, they have 18%. So out of this, we can easily say that, yes, these are the 4 major campaigns who are sending the spam emails. Similarly, we observe the same result of the data August 20. See, if you look into this, again, we have like 4 major campaigns. I'll show you what are the campaigns. You might be interested to see what they are trying to promote. And in 21 August, again, we have the 4 major campaigns. So in every cases, like almost 90% spam emails, like no matter how much data we process, in every cases, we found 4 or 5 major campaigns out of that much spam emails. So here are the products for you. See, first one is anti-aging. Like 36% of these spam emails actually promote anti-aging pills. Then 32% they promote weight loss pills, and 18% promote weight loss solutions. They are actually 2 different type of promotion. And then 5% of spam emails was about Viagra, and rest of them are like 9%. So this result, this chart is actually generated for the data of 15 April. So I think I am almost in the end of my slide. So as we have the data for a different time period, we were curious to see are the same campaign is repeating or no over the time. So what we did, we found like three major, these are the like redirected URL of major campaigns. So if you look into these, first two are first two appeared in the campaign of 15 April. Third one appeared in 15 April as well, but first two is not available for 20 and 21 August, which means they promote that time, then they didn't promote in the month of August. But the third one was repeated in August. Similarly, in August, we have two dominant redirected URL, the last two, but they didn't appear in the data of April 15. So this is kind of interesting. So now, like, we are interested to find like which type of campaigns actually like repeated by time. So now I am in the conclusion. So here is the conclusion. First thing is you might know that there are too many standards to detect spam emails. They use like blacklist or content based or many type of algorithms, but they are actually not dynamic. For example, you know that okay, these are the blacklisted domains, these are the blacklisted IPs. So you apply them to your server to do the filtering. But this one actually can be applied to the real time. Now, in our case, like as we don't have like access to real-time spam email, so we are given the data set, we apply our algorithm to that. But now our center is interested to apply this thing when the spam email arrives to the server. So it can be applied directly as we don't have like any predefined list or any predefined algorithm. It can like on the fly, it can detect the redirected URL and match the subject and find the campaigns. Similarly, I have already showed you our claim that almost 90% of the spam emails from the given data set is point to a 4 major campaigns. So we would say this is a like huge improvement or gain of our algorithm. And it can detect the campaign consistently, as I have already mentioned you, like if even the spammer changes their URL, it doesn't matter, because eventually it will point to their original website, so it can be detected easily. And no matter even if it changes their subject, because we are matching this subject, once we found the redirected URL in level 2, we are matching the subjects. So it can be applied as well. So here is the like, if you think like another view or conclusion of our research, what we can do. Like we have to change our mind towards the spam email, right? As we know, these spam emails are harming other people, and sometimes you don't even know. Like you are infected and you are helping two spammers. Like you are not aware, but you are helping them to harm other people. So we should like need social awareness to address this spam campaign, community awareness, and we need law enforcement to stop this kind of campaigns or to face this kind of campaigns. So this is question time. So thank you everyone to listen to my presentation, and I am ready. Like if you have any question, I will be happy to answer.
Any questions?
Yes.
Several questions actually. Which cluster algorithm did you use to identify clusters?
Oh, initially we use Dibya scan. We applied Dibya scan and optics as well, but later we didn't like at the beginning. We started with the like subject matching. That time we applied the Dibya scan and optics, but later we didn't have any specific clustering algorithm. We just merged them based on their redirected URLs. Oh, actually, to answer your question, when we apply like the Dibya scan and optics, our performance wasn't better like this. So this is why we discarded that algorithm and straight away matched the redirected URLs.
Say it's a real-time solution. How fast can you apply your threshold?
Oh, yeah, this is a good question. I was actually expecting this question. At the very beginning, we didn't realize that when we process a given URL to find the redirected URL, we thought that it has to be processed one after another. But after a certain period of time, we realized that, oh, it can be processed like parallelly. So then it actually like for the almost 500,000 spam emails, we got the redirected URL within 10 minutes. So at the very beginning, we thought, okay, let's process one by one. So it took like 2-3 days. Then we thought, okay, why don't we do it like parallelly? Then we did it parallelly, and we are able to finish it by 10 to 15 minutes.
So the thresholds for merging the outliers is also real-time?
Yes, yes, yes.
And how do you identify or how do you deal with false positives, if there are any?
Oh, yeah, this is, we didn't consider this case just because the center who is like providing this data, they actually ensures all of them are spams. So we didn't have to consider that part. Yeah, but once we, this is a good part, we know that maybe we have to consider this case because at the real time, if we apply this, we have to like confirm that there is no false positive, right? Yes, thank you for that question. Any more questions?
No questions?
Seems like everyone is convinced with their like spam campaigns.
Thank you, Abu.
Okay, thank you very much.